Right, there we go. That's what we wrote down yesterday. Okay, so the heading was angles on intersecting lines. All right, and then we discussed corresponding angles, which is if you have two lines that are parallel and you have a line cutting through those two lines. Remember, we call that line the transversal. All right, then if you can identify an F shape, so we did one in pink. We said that the angles on those two parallel lines, or underneath in this case, I suppose, will be equal to each other. Then we have a backwards F shape as well. So those are the light blue angles. Those will be equal. You could have an upside down F shape. Those angles will be equal. Or you can also even have an upside down backwards F shape. And then in that case, those angles will be equal. All right. Did anyone have any questions on that type of angles? Okay, corresponding angles. All right, the second type that we're going to look at is where we have alternate angles. And for alternate angles, we're going to look for a Z or an N shape. Oh. All right, I'm going to draw that same diagram again, but then I'm going to draw a different one next to it. Right. Okay, you can just copy those diagrams, please. Yeah. Mm-hmm. Mm-hmm. They can be straight, it's fine. As long as you draw them so that they look like they're parallel as well, yeah. But they don't have to be skew. You can draw them straight if that's easier. Now, guys, the reason why I've used two arrows on both of these lines is because you'll see that when we are actually doing examples, if you have multiple lines that are parallel, all right? So I could kind of have crossed these lines or these two diagrams, I could have combined them. Then you can't use one arrow on lines that are parallel like this, and then one arrow on lines that are parallel like that as well. All right, you need to have different, it's almost like when you have, you guys done diagrams where you have equal lines and then another set of equal lines. Do you guys know how to indicate when lines are equal to each other? You have that one little thing on the line. Have you seen that before? So something like this. All right, that will show that this line is equal to that line. I'm going to erase it, don't fill that in. All right, but then if you have other lines in the diagram that are also equal to each other, you wouldn't be allowed to use one line again, you would have to use two lines. Okay, it's the same kind of concept. Let me just erase this. So I am just showing that these two lines are parallel to each other, but not to these two. Right, does that make sense? So the ones with one arrow are parallel to each other, and the lines with two arrows are also parallel to each other. Okay. Now, guys, if we're looking at this first diagram, I want you again to take a different color pen or a pencil or a highlighter. It's up to you. I'll use my pink pen again. The Z shape that is easy to see is if we highlight that line. You just have to highlight a part of it. You don't have to highlight the whole thing. And then this line, the part of the transversal, like that. And then that part of that line. All right, do we see that that's a Z shape? Now, if you can identify a Z shape, then we call the angles that are like on the inside of the Z. We call those angles alternate angles. And guys, please note it's not alternating angles, it's just alternate angles. All right. So for the F shape, it's the angles that are almost on the same side of the line. So it's underneath the lines or it's above the lines. For alternate angles, it's the angles that are on the inside of the actual Z. Right? Does that make sense? Now, guys, if alternate angles lie between parallel lines, those angles will be equal. All right. And again, we can see it just by looking at the picture. We can tell that that angle should be equal to that one. All right, they look like they're equal. And guys, again, if this line, say AB, was skew like that, would this angle still be equal to that one? No. All right, so they have to be parallel in order for them to be equal. Okay, is there a backward Z shape that we can maybe identify here? Yeah, it's a bit of a weird shape, hey, because it's almost like a stretched out one or a flatter one. But if we look at that line going there, and again the transversal, and then that line going there. Okay, so now we're gonna have to kind of go over the pink. But I do want you to actually draw it in. All right, so that one there. Kind of along the transversal and then going back like that. This is like a stretched out one, right? Now again, because these lines are parallel, this angle will be equal to that angle there. Right, so it's like the angles that are in the Z in a sense. Okay, if we just look at the other diagram, here we can't really identify a Z shape, but we could identify an N shape, all right? Just because the parallel lines are now in a different kind of orientation. Do we notice that we have like an N shape going there? Okay. All right, I'm not going to draw that in. Let's see if we can figure out which angles. All right, it is sometimes helpful, especially in the beginning, if you just kind of trace the N using your pen. You don't actually have to draw it in. All right, yes, Nicholas? So there, yeah. Okay, that one there, and then that one there. All right, so if we're calling this an N shape, all right, it's almost like on the inside of the N, of the corners of the N. All right, but we can also do like a very weird kind of flat N shape. If we look at that one there, right, that's a bit more difficult to see. Do you notice that one there? All right, so in that case, if we have this shape, then that angle over there is going to be equal to this angle over there. All right, once you practice these, it will become easier to see them. So don't worry if it's a bit confusing at the moment. Okay, I'm just going to write the actual rule down here. Alternate angles between parallel lines are equal. Griffin, can we get also sound, please? Right, and that's actually quite useful, guys, that the angles are always between the parallel lines. All right, for corresponding angles, they were on or underneath the parallel lines. For alternate angles, they're always between the two parallel lines, those angles. All right, on the inside of the Z or the N. And then the reason for this, whenever you use this, you would have to write in brackets alt angles. And then because they are only equal if they lie between parallel lines, you have to, again, just like with corresponding angles, you have to state which lines are parallel. So in the first diagram, we have that AB is parallel to CD. And then just underneath this one, I'm just going to write the reason that we would use for this diagram because we have different lines here. So you would say alt angles. And now which lines are parallel in the second diagram, guys? J, yes, Nicholas? Yes, so GH and IJ. All right, it doesn't really matter what order you write those letters in, as long as you just have the two lines. So GH and IJ. Okay. All right, I think I will be able to fit the third one in on the rest of this page. Let's see. So the third one is co-interior angles. Right, and that is a C or a U shape. I'm going to draw the same diagram that we had since the start. Yeah. No, it's just to help you to be able to identify. Right, I'm not going to draw the second diagram, okay, but we can refer to it if we just look up to that one. But if I draw the second one, I'm not going to be able to fit everything in. All right, guys, now if we look at this diagram, sorry, am I a bit too fast? Okay, let me just give you a second. All right, obviously now a C is a round shape and we have no round shapes over here, but you can kind of tell that we have kind of a C shape over there, right? Does that make sense? So it's not really a C, but it's like a blocky C, I suppose. All right, so let's just color that one in there. So that is what I mean when I say a C shape. So yeah, it's not really a C, but it does have that kind of orientation, I suppose. Now guys, co-interior angles, the name is kind of telling you which angles you're going to look for. Co, all right, so they kind of work together. Interior, so they're going to be the angles on the inside of the C shape. So this angle here, now I'm not going to put dots in. I'm going to do this rather, all right? Because in this case, guys, if we're looking at those two angles that I've now kind of indicated, do they actually look like they're the same size? Definitely not, hey? Now the thing with co-interior angles, they are different from the corresponding and alternate angles in the sense that they are not equal to each other, but if you add them together, they are going to add up to 180 degrees. All right, so that's the thing with co-interior angles. So for example, if this angle here is 70 degrees, that one will have to be 110. If that one is 80, that one is going to have to be 100. All right, so these two angles will always add up to 180. I'm going to write that down just now. Let's just quickly identify another C shape that we have here. So here we have a backwards one. All right, so let's do that one in the other color that you've been using. All right, again, hello. Yes, we can come in. Yeah, it looks like we're all full. Is there a chair there, Ethan? Okay, cool. All right, so here we have that C shape, and now again, co-interior angles. So the two angles on the inside of the C shape. All right, I'm going to use the same notation, but it's fine because we're in a different color now. All right, so again, those two angles, they're not equal to each other, but if we add them together, they will be equal to 180. All right, so let's write that down. Yes. Mm-hmm. Just, you can if you want to do that, yeah. Co-interior angles are, and now I'm going to teach you a new word. I'm not sure if some of you might know this. Supplementary. Have you heard that term before? All right, co-interior angles are supplementary. And guys, that word means that they add up to 180. All right, so we can just put that above the word. Add up to 180 degrees. All right, so there is the expectation that you know what the word supplementary means. All right, so just remember that it means that they add up to 180. Now, the reason that we'll use for this is co-int angles like that. And guys, this will also only be true if they lie between parallel lines. All right, so maybe I should have added that to the note. Maybe, sorry, let's just do that. Okay, my apologies. Can you just add that in? So co-interior angles between parallel lines are supplementary. Sorry, that is actually very important. Okay, if these two lines were not parallel, so again, let's imagine if AB was kind of going up like that, then the two angles would not add up to 180. Okay, so just like the other two, the lines have to be parallel. And then just like in the reasons for the other two, you write the types of angles that you have or type of angles, and then you write the lines that are parallel. Okay, it will be 1 mark for the reason, and if the parallel lines are not there, you're not going to get that mark. Okay, so that's very important. Right. Now I want to just show you guys a little kind of a summary of the different angles that we've done now. It is also in the note, but I do want us just to write it down. So we've done 3 types of angles now that the rule only works if they lie between parallel lines, all right? But we've also done angles on a straight line, and we've also done vertically opposite angles. Okay, so I just want to show you what this thing looks like. All right, funny X. Some people call it fuzzy X. I actually prefer fuzzy X, so that's how we're going to write it down. But that is like a nice way of remembering the 5 different types of angles with regards to straight lines that we've done. All right, so the F is for corresponding, the U is for co-interior, the N or the Z is for alternate, the Y is for angles on a straight line, and then the X is for vertically opposite angles. All right, so we're going to do that quickly. We're going to draw that out. So let's just write summary. And now we must just, try your best to space it out nicely. It might be a bit difficult. And we are going to draw these so that they actually look like the letters that we use to remember them. Okay, but obviously sometimes they might be skewed. So if we have that these 2 lines are parallel there, just writing corresponding above. And we would have that angle equal to that angle. Guys, it's okay if you don't fit them all into one line. Okay, please don't stress about it. Yeah, in terms of having them all the same height, I think let's do an N like they have in the notes. Otherwise, the Z is going to take up too much space. Please, this quickly so that I'm not covering everything. you don't need parallel lines. So only for the first three do you need parallel lines, and for the other two, they must just be straight lines. Okay. Okay, guys, so does that make sense? That's a nice little summary, all right? All the different types of angles that we're going to look out for. We are actually going to do an example now where we need to find the sizes of angles using some of these rules. Okay, now guys, sometimes also it's possible to use more than one of these to find one angle. And then in that case, it's fine. It doesn't matter which one you choose. Okay, we'll see now when we actually are doing an example. We'll discuss some different methods. All right, so let's just do example. Yes. So I've written here what P and Q are. So we'll discuss that now. Just write that down. It's not the end points in this case. It's something different. Okay, guys, they're talking about P and Q here, but they didn't put it on the picture, all right? But they are telling us what P and Q are. So they're saying that they are the points of intersections of AB and CD and the transversal, all right? Now, if we look at AB, it is being cut or intersected by this transversal, and that point where they are cutting each other, that is the point of intersection. All right. So it's a bit difficult to actually fit in a P over there. All right. But just kind of write it somewhere. Maybe they're above the 115. But just keep in mind that P is not an angle P is actually that point. All right. Yeah. Well, if P and Q are 2 points on it, then we can call it PQ, and we don't have to call it something else. All right, so guys, does it make sense that P is that point there? So what am I going to call this angle? Angle P2, right? This angle is P3. That angle is P4. Remember I told you the other day, if there are these numbers without the degree symbol, that's not saying that this is 2 degrees. That is a way for you to name the angle. All right, so you call it the point that where that angle is, and then that number. All right, so this point, this angle, sorry, is angle P2, P3, and P4. All right, we don't need to give this one a name because this one is already given. We're not going to calculate this one. All right, but I suppose this one would be P1 if they were to give it a name. All right, but we don't have to worry about that. Then this other point of intersection. So the point of intersection of CD and the transversal is Q. All right, so just add that in there. So that's saying that all of these angles around this point are going to be called Q and then the number that they've written there. Okay, so this is Q1, Q2, Q3, and Q4. Okay. Now we need to find the sizes of those angles, guys. Now they haven't told us that we need to do it in any specific order, all right? Sometimes in tests or exams, they do say that you have to use a specific order. For this one, we're just kind of going to go with whatever we can see first, all right? And there will be many different ways of finding these angles, guys, all right? So we're going to discuss all of them. Can we try and find, if we're looking at this 115 degrees, what would be the quickest angle to find first? Vertically opposite, hey? Which angle is vertically opposite 115? P3, not just 3, P3, please, we need to be specific, all right? Because there's a 3 there as well. So these two angles are vertically opposite. If we look at that X shape, all right? The X, a fuzzy X, that's vertically opposite angles. The angles that are opposite each other are equal. So we're going to write P3 is equal to 115 degrees. And then you need to write your reason. So in brackets, you're going to say vert op angles equal. Okay. Now, guys, what's quite useful is when you are actually calculating angles, just fill the values in as you go, because you would normally be able to use the angles you've already calculated to get some more of them. All right, what can I find next? Hands up, please. Want to hear from someone else, Joseph? P2, yes, using? The co-interior, not at the moment, because remember co-interior is when we have a C shape. So those two would be co-interior. Oh, Q2, sorry, I thought you said P2. Okay, yes, that is true. All right, let's do that. Let's write that down first. Q2 we can find using co-interior angles. All right, my apologies, I misheard. All right, so now, guys, the way in which we're going to write this, we're going to say that Q2 plus 115 should equal what? What do we know about co-interior angles? 180. All right. So these two angles together, are we seeing that C shape? Right? Those two angles together should equal 180 degrees. Then, guys, as soon as you're using that rule, you need to write the reason down. So co-interior angles. And now we also need to state which lines are parallel. So AB is parallel to CD. Guys, if they didn't tell us that those lines are parallel, we couldn't use co-interior angles. Okay? That's very important. Now, what must I do to figure out what Q2 is going to have to be equal to? Can we hear from someone else? Someone else? Okay? Yes, Eve? Yes, good. All right. The opposite of adding 115, which is what we have here, is subtracting 115. All right. So we would say that Q2 is equal to, now you can write the step in, you also don't actually need to, it's fine if you leave it out, but that is the working that you would have to do. If you can't just do it, sometimes it's easy to just see what the value would be, all right, then you can just write the answer. Now what is that, 180 minus 115? 65, all right, so Q2 is 65 degrees. Good, let's fill that one in. Okay, what next? Martha, you wanted to say something earlier?
I wanted to say, you can solve angles on a straight line.
Yes, we could find P2 by using angles on a straight line, right? Because 115 and P2 must then equal 180. Isn't that the same working that we had here? Right? It was just for co-interior angles. But guys, co-interior angles and angles on a straight line are similar because they do have to add up to 180. Okay, so that's a good option. We could use angles on a straight line. But do we notice a shape maybe for looking for P2? And we are keeping in mind that we have Q2 already. Yes, Nicholas? We have that upside down F shape, hey? Do we notice that? Yes, corresponding angles. Okay, so angles on a straight line is perfect. I just want us to look for these shapes as well. So guys, are we noticing that F shape there? Right, and what do we know about the F shape? They are corresponding angles. So P2 and Q2, and if they lie on parallel lines, they will be equal. All right, so P2 is also going to be 65. And the reason there could be angles on a straight line, oops, sorry, I'm writing my reason wrong, or corresponding angles, where you have to write it like this. There we go, my apologies. Corresponding angles, and then you would say AB parallel to CD. Now guys, if P2 is 65, what's P4? Also 65, hey, because of vertically opposite angles. But even if we didn't have P2, don't we have a Z shape there? Hey, do we notice that? That Z shape. So we could use alternate angles as well. And because these P4 and Q2, because those two angles lie between parallel lines, they would also be equal. All right. So you could either use vertically opposite angles if you're using P2, or you could use alternate angles. Or what else could I do, guys? If I'm looking for P4. Angles on a straight line. Hey, I could do that as well. 180 minus 115. I'll get that answer. What about angles around a point? Do we remember that one? We haven't actually used that one. But what does angles around a point say? That all the angles around a point should add up to 360. All right, remember the other reason for that is revolution. So you could even do that, guys. You could say 360 minus 115 minus 65 minus 115, and it would then give you that answer. Yes?
Are we allowed to, if we just solve the top four, then we just flip the bottom one over and then just rewrite that?
So they would have the same values, but you would have to have a reason for each one. So you couldn't. It would be the same values, yes, but your reasons would have to work with it. So it would be the same except for the first one, the one that you're linking. So we have a linking one here, which is the 65. But you couldn't. So for example, for our P3, we used vertically opposite angles. If you had nothing here, you couldn't just use vertically opposite angles for Q4. You see what I'm saying? So you would have to have a link first, and then you would go from there. But yeah, it would work. All right, guys, so P4 is also equal to 65 degrees. Now we listed lots of different ways in which we could find that. Is it fine with you guys if I write alternate angles, just so that we have a mixture of reasons? Remember, alternate angles is the Z shape, right? So because we have that Q2 is 65, P4 will also be 65, all right? So alt angles, AB parallel to CD. Yes.
I'm sorry, I need to ask.
Mhm.
When you have to do this stuff in practice,
Yeah.
what will the time allocation be? Would it be longer than the previous one or the-
What do you mean for your test week test? It's an hour and a half for 75 marks. Okay, so now we found many of them. All right, let's look at the bottom. Yes, Michael?
Q3 in 65 because of that.
Mm-hmm. So Q3 is also 65 because of vertically opposite, or do we see that F shape? All right, so we could use corresponding as well. So Q3 equals 65 degrees. Let's use vert up angles. Okay, we have two more left to go. All right, Q1. Yes. Yes, okay, good. So we can use alternate angles for Q1. If we use that kind of stretched out Z shape, do we notice that? All right, so Q1 is going to be 115. Guys, you could also use corresponding angles, right? The F shape for Q1. All right, yes, Michael? You could use co-interior, yes, with that 65. All right, or we could also use angles on a straight line. All right, so there are lots of options there, guys, and you basically just write down the one that you see first. Okay, it doesn't have to be a specific one. So Q1, the one that Stella said first was alternate angles. So we can write that. I'll show you now. I'll put in all the ticks. Okay, so that would be 115 degrees. And then Q4 also 115. All right, because of many different options. Can we just write vertically opposite? Is that fine with you? So Q4 equals 115. Vert op angles equal. Okay, now in a test or exam, this question was quite repetitive in the sense that you kind of could have just even used the same 2 or 3 reasons all the way through. So you probably won't get a question that is exactly like this, all right? You'll see when you're doing questions in the textbook, it will be more kind of varied. They might throw some triangle stuff in. Have we done triangles? Not. Yes, no. Okay, so that will come later, all right? But it won't, they might give you something like, yeah, maybe like that, where you only have to find like Q2, not all of them, all right? But basically you would get 2 marks for each of them. So it is 1 mark for the value and 1 mark for the reason, all the way through. All right, so like I said, this is a bit of an unrealistic question for test purposes, all right? But we can put in all the ticks. So it would literally be like that all the way through. All right, so this specific question, yes?
If you forgot to put the reason, would you still get a mark?
So you would
Plus
get,
the angle.
yeah, so if you forget to put your reasons, you would only get the angle marks, which means that you would get 7 out of 14. All right, which is a shame, guys, because obviously if you can get the angles, then you know what's going on. All right, but you would only get 50% if you don't put your reasons down. So it's very important, guys, please. Reasons are very important. They literally count half of the mark. And sometimes, especially in higher grades, so in matric, for example, you only get 1 mark for the whole thing. So for the reason and the angle together. So if you only have the angle, you're not going to get any marks. All right, so that's why we need to get into the habit of writing those reasons all the time. Yes.
When we write vert as the reason for vertically opposite, we have to write the angle that it's opposite.
No, so for these, you don't actually have to state any angles. All right, I know in the note they did that in the one example, but they just kind of did it so that you could see. The only thing that you have to fill in is the lines that are parallel. Okay, but you don't have to write any angles in here. You can just write the reason. Okay. All right, guys, you're going to practice a couple of these on your own for homework. So in your platinum textbook, you are going to look at the revision exercise on page 1, 4, 3. And I want you to do numbers 1, 2, and 5. Just see how much time is left. Okay. Right, write that down, guys. I'm just going to check with you what that is. Because that's what they said in the note. Yeah, okay, yeah. I just want you guys to do those ones. And just check 15, 16, 17. Yeah, it's fine. You just have to do those 3. Right, and then we'll do some more practice tomorrow. Guys, it's a good idea to have that funny X summary just kind of in front of you while you're doing these. It makes it easier to find sets of angles that you can use. Right, that is what you're doing now, guys. If you don't finish it in class, it becomes homework for tomorrow.